In this video, you will learn how to implement Mediator Pattern in Swift. I'm going to show you two demos, one with the basic idea and another with SwiftUI to solve a problem that happened to me a few days ago. Let's jump to the code. Here I have a class user. This class is representing a chat room where I can talk with other users and I can send and receive messages. As you can see here, this class user has a name, contacts representing other users. We have a function to add a contact. We have the way to send messages. If we send a message, we will send it to everyone and also receive the message. Now, here is just the basic idea of running this demo. And let me do it. Okay, we can see now that we got messages. Alice sent hello, Bob received hello, Charlie received hello. Okay, this is cool. However, in this little demo, the problem with this is that, the user is doing this. And also, since that we have the contacts, well, we are doing also the work of sending and receiving the messages. But the problem is that if for some reason I have more kind of users or something else that needs to be interacting with the user, well, I will have to also add that set of components here to understand what's going on there. So this can become really messy at some point. So the point of Mediator is to try to coordinate things across multiple objects. In this case, instead of the user handling every single message back and forth itself, well, the thing is having a dedicated object instance to do that for us. And then from our end, as a user, we will just send what we want, okay? But without even getting the context of other users, because those users can be anything, right? It doesn't have to be the same user like this class, could be anything else, but someone else will coordinate, will add them, etc. So there are many ways to avoid issues and just concentrate of one single thing, which is just talking about myself as a user. So for this demo, what we're going to do is implementing a protocol called Chat Mediator. But the only thing this protocol will do is sending a message. We will send a message and we will indicate what is the user that is sending the message. Okay? This is a really simple coordinator, but you will see the difference in just a moment. Now this protocol will be implemented by another class. In this case, I have an actual chat room. Here we are conforming the protocol Chat Mediator. Okay, this chat room will hold all the users instead of this user itself doing it. Now here we will concentrate all the users interacting with each other. We will add a function add user that will add a user to the chat. We will add it to the array of users. And here we have something really cool that you will see in a moment. We will have to implement a set mediator in each user. In this way, we will understand that some other entity will take care of all related to the chat, okay? Not the user, something else. This is kind of how we implement data sources in table rows. Do you remember when we use UIKit? For those that you are using it, well, that's kind of the similar idea. So like delegating this to other objects. And of course, we have the send message. So here, the only thing is that if we are the same user, of course, we don't want to send the message to us, right? We want to send it to the other people. That's the only thing. Now, let's implement this. What we're going to do first is getting rid of context. We don't want to know anything about it. But we will implement this, the chat mediator. Whatever it is, well, we will create it here, and it will provide what we need for the chat. We're gonna get rid of this because, again, add contact, it's not the responsibility of the user anymore. And instead, now we are adding the method to set the mediator. In this case, it's as simple as this. Now here is the interesting part. We, at the beginning, had to use this send message to send the message to all the contacts. However, this won't happen anymore. The only thing we have to do is now call the mediator.sendMessage, and we will send the message, whatever it is, for the user. And what is the user? Self. It's that simple. Now, receiving message is the same, so we're good to go. Now here, of course, there are a couple of things that we will change. First, we will create the chat room. And now instead of having this mess, that by the way, this is one of the issues that we had before, that each user had to add itself, and this is a mess, right? I need to add, user 1 needs to add everyone, user 2 needs to understand everyone else, so it is chaotic. So instead of that, we have this, add user, and we added 3 users in one shot to chat room, and that's it. Now, everything is managed by this chat mediator, or, well, under the hood, it's doing chat mediator, but here we have it has a chat room. Now, if we run this again, let's see what happened. There you go. Again, Alice sent hello everyone, Bob received it, and Charlie received it. This is cool. So I think you got the point of the idea of what Mediator is doing. Let's go back again. Instead of user having to manage all the contacts itself and then adding them one by one across other users and making a many-to-many situation, now Mediator is just coordinating everything. And, well, if we need to send a message, we will call the mediator, hey, I have a message for you, do it, right? And this is actually acting as the chat room that we have. Or the hood is doing that. So, and here then we will coordinate all the ceremonies and things to communicate across multiple entities, in this case users, but could be anything else. Could be UI elements, could be, I don't know, views, etc. So there are many ways that, or many objects that need to coordinate each other. And instead of having a graph or thousands of connections, you can just centralize that work with just the help of one entity, or it could be many, right? But the point is just coordinate the work of many entities around. Now that you got the point of what is Mediator doing, let me show you something that happened to me a few days ago in my job. Something that I had to, well, not me, maybe my team, but I'm just trying to extracting the point of the idea of what happened to me. And it's really interesting because probably it will help you if you have a SwiftUI application like me. Okay, I have this demo here. I have 3 buttons. Each of the buttons has different kind of operations. This one has a quick action to do. It was just taking 1 second. This one has, I think, something longer, like 4 seconds. And the third one has an even longer operation, like around 6 seconds. Okay. So let's wait. There we go. Now the thing is, I can execute this task along with other, right? I'm executing task 2 and task 1. Okay. Nothing happens, right? That's the way we should expect if you press a button. Now the problem is that I had an application that is communicating with an API and with a hardware device, right? And sometimes your hardware, let's say you're communicating with an Arduino thing or something like that, or something that is not running multiple tasks at the same time. So if you try to manipulate that and send in many messages to a hardware like that with that limitation, well, you maybe found a lot of issues. So here, what I wanted to do is trying to coordinate the work of sending tasks or sending operations to that particular piece of hardware. Now, what is the problem? I have to consider other areas of the application, not only one screen. So for example, here, if I run this task, I can go to the next screen and I can execute any other kind of task across multiple views. This is problematic because if it's just one single view, well, okay, I can just put maybe a boolean or something and just indicating, hey, I just have to finish this task before running the next one. But if it is across the application, I will have to then read what's going on outside with other buttons, etc. And that can be a little bit chaotic, right? So I want to avoid a lot of disruptive changes in my design. So one way I solve it, well, actually, thanks to my team, we solved together, was trying to centralize the problem, thanks to the Mediator pattern. And even though it is slightly different from the theory I just showed you, which is not, I don't have a set of buttons that are communicating each other, but I will implement something that the buttons will communicate first, like the mediator, to understand, can I run a task? Yes or not, okay? If I can run the task, go for it. If I cannot run the task, my only action here will be just ignoring the operation and then waiting until I can, all right? So if we go here, I want to explain a little bit the code just to get a better idea. So nothing crazy, as a normal button here. And I'm running the task here. So yeah, it is just sleeping a task for 2 seconds in this case. And that's it, okay? So now I have a second view here, which is a cool name, by the way. And it's the same, okay? So nothing serious. Now, again, I could start typing something here to say, okay, let's create a state and disable the button or do something like that. But the problem is that I want a centralized way to do it. So in this case, if I have to use, let's say, an environment object, how I will do it? Should I have to implement this environment across all the views? And the answer is not. Actually, I can create a custom button that will call a normal button. And under the hood, it will call a mediator that will understand what is running at some point of the time. So we're going to start then creating something called Task Mediator. And we're going to start from template, Swift file. I'm going to use Task Mediator. There we go. Okay, here we go. Now here, the only property that we will use, it is an ID. Why we want an ID? It's just to understand what is the button that is executing something, right? We just need a UUID, actually. We don't need exactly a reference to the button, so we don't care that. It is just to understand that a button is starting an execution, and that's it. If there is an open ID, an active ID, we will just ignore the request of starting another task from a button. So now, what I'm going to add here is just a method, start task. I'm going to do it, just copy pasting, because I don't want to code this. It will be a little bit boring, but you can take a screenshot if you want to use it in your own code. So here, I have this function, start task, and I have this button ID, which is a UUID, as I said, and this is an action, a regular action from a button, so nothing too much to say. And here is the interesting part. If we don't have, we're expecting that active button ID is nil. That means nothing is running. If for some reason this is not nil, this means something is running and we return. We don't do anything. Now, if there is nothing here, now we establish, okay, that there is a button ID executed, and we want to say that we are executing a task from button and with some button ID. We will execute the actual action from the button, and once it's done, we'll just say, okay, active button is nil, okay? So we are releasing, locking and releasing, if you wanted to see it in that way, right? That's it. It's not too much code to add, actually. Now, as I said, I don't want to add this task mediator in every single screen. I mean, I have 2 here, but I could have many others, 10,000 screens. I don't want to go one by one and add this environment. Instead, what I will do is creating a custom button that will call a regular button, and there, just in one piece of my code, I will call this task mediator. And all the buttons that will require this functionality of just listening if there is a task running or not will have to use this button. I'm going to create another file here from this template. I will call it task button. Actually, I will use SwiftUI here. I will create it, yeah, of course. Body, there we go. There we go. Okay, what are we going to need here? Well, the first 3 things are simply an ID to understand what is the button ID, the action that you saw already from a regular button, and the label. If we want to customize this button, we can do it without any problem. We're going to create this init where we have the action and we have this view builder with label. If you want to learn more, by the way, about view builder, which is really powerful, I will leave you, a link in the description with one of my first videos where I talked about view builder. Now let's fix the body. The body will call a regular button, as I said, okay? And here we can add the label, okay? The regular label here. That's it. Now the action. This is the interesting part. So here, instead of executing the action directly, we will then call the mediator, the task mediator object. And to do that, we will have to implement it through an environment object, okay? Of course, it's failing because we need to confirm the task mediator as an environment object. Let's go back to the mediator, okay? And the first thing here, if you're running iOS 17, it's using observable. Yeah. If you want to learn more about observable macro and all this migration to the newer property wrapper, I will also leave a link in the description, where I made an article explaining all of this in detail. It is really good. And lastly, let's go back here, because if we want to implement this as an environment object, we will need the environmental values. But instead of creating this piece by piece, I'm using the new entry macro, which is really convenient. If you can use it, go for it. If not, use it using the static properties like this. So, if you want to learn more about it, I need to use SwiftUI here too. Okay. There we go. Yeah, I can see now the macro. Yeah, there we go. This is like the, auto-completing what you have to do manually with our entry. And by the way, I'm also leaving macro videos if you want to learn more about creating your own macro like this one. Okay, let's go back now to the tasks button. And there we go. Okay, I was just scared. Here we have everything. We have the mediator. The mediator will tell us, okay, if a task is running or not, if a button ID is, doing something. And now here, since this is a button, it is executing asynchronous code. Well, we'll have to use task to enable the asynchronous operation. And here we will use await, and we will call the mediator. Mediator will tell us if we can start task or not. Okay, and the ID is ID. There we go. And the action will be the action. There we go. Now, again, button, instead of calling button directly, we will call task button here. Okay. And this button will call start task. Start task will come here and we'll check if there is an active button executing something. If it's the case, we will ignore it. Otherwise, we will start the process. And we will be able to start another process until we finish that. Okay. Now let's go back to the code. Now instead of doing a lot of replace or refactor here, the only thing is just using task button. That's it. Let's put it here. Okay. And let's go back here to copy pasting here. Okay. Is everything fine? And now let's do one more thing. So instead of using this task here, we will create this as a sync operation, and we will remove all these tasks. Actually, I can do it right away here, just copy pasting. I think it's way more faster than one by one. Yeah, there we go. Yeah, and now I can, since that this task button is accepting a sync task, well, I can just go for it and getting rid of the task. Let me do this to the other set of tasks. From here, there we go. Okay, yep, cool, okay, that's fine. Now, let's run this and see what happened. Okay, let's try to run this long test. And look, I can't run anything until it is completed. Nice. Now I can execute. Okay, there we go. What happens if I click it? No, I can't. I just can execute something one at a time. Okay. Now, even though this works, if I press this and I go here and I want to execute something else, yeah, it is responding back and forth. Now, if I want to execute the task number 6, if I want there, no, I cannot do it. This is great. Okay. For the purpose of this, it's also useful for, when someone is trying to force multiple things, like, typing too fast, and maybe that's breaking your logic. I don't know if that's your case. But from this idea, you can explore it. You can maybe reduce it. Instead of having this active button, you can just simply use a Boolean, or you can make it more complex. Instead of, you can create a debouncing process, like maybe instead of blocking and just having to wait until the end of each task, maybe you can add just a delay of X number of seconds or milliseconds, and then just to avoid quick tappings or things like that. Or, I don't know, the sky's the limit. It's up to you. But I'm just showing you that thanks to Task Mediator, you can centralize a lot of code just to, understand, review what's going on, and then delegate to that piece of code to do that in particular, and then send message across other objects. I want just to end this video saying one thing. If you have been working in iOS for years, well, you have been using Mediator all that time. Why? Because if we go to the concept of MVC, the C, the coordinator, is actually a mediator. Yeah, the controller is a mediator between two components, the model and the view. They are not connecting each other. But yeah, you got it. You sometimes are using something without realizing that there is a dedicated concept like mediator in this case. Well, that's all for this video. If you want to learn more about design patterns or anything related to Swift, please let me know in the comments down below. And by the way, I will leave more articles about some other patterns that I have reviewed, not only in YouTube, but also in swiftandtips.com. Yeah, my website. That's all for me. Thank you so much and have a great day.